So we're going to cover ID tests for alcohols now. The first one is oxidation using potassium permanganate, acidified, or Cr3 or Cr2O72- acidified, which I've already covered in the previous video. So if you need a revision for them, go back to it. The second one that I'm going to cover is another oxidation reaction, but this time it is with phthalenes or Benedicts. Okay, so these are effectively, both of these are effectively the same chemical. So they are copper 2+ ions, and they're dissolved into a solution. And what we do, we add them to an alcohol. The alcohol get oxidized, and the copper gets reduced to copper 1 oxide. So it gets reduced to copper 1 oxide. I'm not going to worry about balancing that properly, but you end up seeing it as a orangey brick red color. So you would observe a color change of blue to brick red, and the alcohol, for example, methanol, plus Benedicts or phthalenes, which is just an oxidizing agent, will be oxidized through to a carboxylic acid, and that will be your reduction reaction. The third type is called the Lucas reagent, and this is a substitution. Reaction, okay, RXN standing for reaction. So Lucas reagent is made up of zinc chloride in a solution of concentrated HCl. So it's really important that you include the conc HCl. If you don't, if you're asked about it in the exam and you forget the conc, then you're wrong, because then it won't be the Lucas reagent. Okay, so the Lucas reagent is zinc chloride in concentrated HCl. So if you're writing it instead of Lucas reagent, you need to make sure you include conc. So what happens is it's a substitution reaction. And it reacts differently with primary, secondary, and tertiary alcohols. So if we are going to react it with a tertiary alcohol, such as 2,2-dimethyl ethane, we end up getting a chloride. So what happens is one of these chlorides swaps for the OH, so you end up with a chloride. Now this is what we call immiscible with water. So immiscible means it doesn't mix. So what you end up with is this is colorless, and when you add this solution to it, you get a cloudy solution from this mixing in. It's sort of like what happens when you mix oil and water, so it becomes an emulsion. If you're doing it with a tertiary alcohol, I'll give you a bit of paper. So Lucas reagent, so plus tertiary alcohol will react immediately. If you are reacting with a secondary alcohol, then you need about 10 minutes and you need to warm it in a water bath. And if you're reacting it with a primary alcohol, then it won't react. Even with heating. Okay, so if you get a question asking you how you can work out the difference between three alcohols, have a look to see if they are primary, secondary, or tertiary, and the easiest way to do it is using a Lucas reagent, where if you mix the alcohol with the Lucas reagent, you get a substitution reaction where the tertiary alcohol will react immediately. You'll immediately get a cloudy solution. The secondary will take about 10 minutes and you need a warm water bath, and a primary alcohol won't react at all, so you won't get any observations. Right, the first one is secondary alcohol because this is the alcohol's carbon. It's joined to two other carbons. So when we react it with Lucas reagent, we need to warm it. And it'll take about 10 minutes. And we end up with right, there's our original, and then we just switch out the chlorine. Second one here, if you look at it, this is the carbon that the alcohol is joined to, and it's joined to one other. So when we try and do it, it won't react because it's a primary alcohol. Final one here, if you look at it, to tertiary alcohol, this is your alcohol's carbon. It's joined to 1, 2, 3 other carbons. So when you react it, it will react immediately. And you will observe, you'll observe a cloudy solution. So this is your original, and then we just need to swap out the OH for a chlorine.